Hey guys, this is the 3.4 classifications of rigid motions. So we've gone over the three rigid motions: flexions, translations, and rotations. Now, what we're going to look at is the composition of two or more of these rigid motions. Okay, so when I say composition, you're going to think of this little circle, right? Composition. It's written like this. And essentially, it's just performing multiple rigid motions to a free image. The thing about this, though, right? So that says N composed of M, right? When you see these, you always do oh, the second one first. Okay, so the way compositions are written, right? They write what you are doing first, second. Okay, so you always do this M part first. Okay, you can see, right? The way they wrote it, N composed of M, right? But they did M first. M was the first prime, and then N is double prime. Okay, so that's very important. You need to remember that. You always do the second one first. All right, so what we're going to do is we're going to first explore glide reflections. Okay, all right, so A, it says, is there a rigid motion that maps ABC to A prime, B prime, C prime? Okay, so essentially, right, we just need to make sure it's a rigid motion, right? Make sure the angles are the same. So, right, we know the angles are congruent or equal, I mean, right? So B, right, you can see the angle the same, A prime and A, right, same size. And then you can see we have a right angle at C and C prime. So yes, angles are equal, right? And the side lengths, right? AC is 2, A prime, C prime is 2, right? All of them have the same lengths, right? Side lengths equal, yes. Okay, so we know, right, there's some type of rigid motion that moves our A, B, C to A prime, B prime, C prime. Okay, now B says, does a reflection, translation, or rotation map? Well, if we look right for a reflection, there's no line of reflection that's going to exactly map ABC to A prime, B prime, C prime, right? There's no line we can draw that's going to do that. So no, right? Any way we can translate? No, right? Because obviously you can see A is flipped over to the other side, right? And then from A prime, C prime, right? And then rotation, right? The only rotation that would really work is 180 degrees, but that would put our B prime somewhere down here, right? So no, we can't do a rotation. So there's no one single rigid motion that can map our ABC to A prime, B prime, C prime. But can we make a composition of two rigid motions that map them? Well, let's think about it, right? Again, we need the A to flip to this side somehow, right? So when we think of flip, we want to look for a reflection. So if we reflect, right, we want to reflect maybe somewhere halfway in between, right? So halfway between would be this line here, which is x equals -1 line, right? So let's try a reflection over x equals -1, okay? and let's just call this line K. Okay, line K. So if we reflect over that, right, we'd have our C here, our B here, and our A here. Now, is there any way we can get this new A, B, C onto A prime, B prime, C prime? Well, yep. If we move down 1, 2, 3, 4, 5 from each point, it's going to land on that. So we can do a reflection over that line, and then we can also translate a translation down 5. Okay, so that maps us onto A prime, B prime, C prime. And how do we write this? Well, right, again, what we did first was the reflection over the x equals 1, -1 line, which we called K. So I write that second, right? Reflection over K. In this first, the second thing we did, we write first, right? And that was a translation nowhere on the x, down 5, right? So we did a reflection first over the line K, and then a translation of down 5, right? And we did this to triangle ABC to get triangle A prime, B prime, C prime. Here's some more theorems that kind of go with this. It says any rigid motion is either translation, reflection, rotation, or the composition, which we call a glide reflection, right? So if M is a rigid motion, right, then it's a reflection over a line, a translation, right, a rotation, or a translation and a reflection, right? So it can be either one of these as any rigid motion, okay? And then any rigid motion can be expressed as a composition of reflections. So, right, if M is a rigid motion, it can be a reflection over L. It can be reflected over 2 things, or it can be reflected over 3 lines, right? So it can be either be a translation, reflection, rotation, or glide reflection, right? And we know we can have multiple reflections as well. All right, so let's look at some more examples of what glide reflection would move our JKL to J double prime, L double prime, K double prime, right? So first, to determine the glide reflection, let's kind of work backwards, right? We have our original and we have our pre-image and we have our image, right? Let's kind of work backwards. So we want to first, right, so work backwards. Right, we know where there's going to be a reflection, right? And then there's also going to be a translation. So we want to work backwards. So we want to find the translation. That sets up a reflection to our pre-image. Right. So, right, we want to kind of line them up. Right. So if we can move our J over 1, 2, 3, 4, 5, right, to right here, and there'd be our J prime. L prime, we move over 5, and then K prime, we move over 5. Right now we have something like this. Right, so translation of 5 units technically to the right, because right
we're going the opposite way. We're working backwards. We moved it to the left, but if you're starting from the pre-image like we would, right, you'd move it 5 units to the right. So make sure, right, your translation is 5, 0. Step 2 says find the line of reflection to get back to the JKL. So we're looking for the line that will move that J prime, L prime, J prime, K prime, L prime to that JKL. So this line, right, is at y equals 1. And we can name this line L. All right, so y equals 1, right, which we're going to call line L, which brings up our third step. And in the third step, what we have to do is we have to write our glide reflection, right, in the composition. Right, remember, essentially we write our translation first, right, which would be 5 units to the right, and a reflection over the line L, right, and that's of triangle JKL, and then that will give us our triangle J double prime, K double prime, L double prime, right, and this is where the line L is equal to the line y equals 1. Right, and that's your solution.
All right, so now what I'd like you to do is try this on your own, right? You want to figure out the glide reflection that will map the following. Okay, so again, right, work backwards, right? Find the translation that will set it up, and then find the line of reflection that will make this work. And then I'll show you the solution. Right, and here's the next one as well. All right, so pause this, try these, and then we'll go over this. So here's our solutions. Again, working backwards, right? You need to go up 3, right? So that means that our translation would be down 3 because you're going horizontally the opposite way, right? So that's why your translation's down. It says down 3, but if you went up 3, you know, your B prime would be, your B would be here, A here, and C here. And then you need to reflect over this line, which is x equals 1. Sorry, -1. And then the next one, right? The solution is reflecting over the line of y equals x and translating 8 down.